Dear 10th standard students, last video class I introduced the chapter numbers and sequence. In this chapter I discussed the Euclidean division lemma and Euclidean division algorithm and also doing the sums from the exercise 2.1. Now I am going to teach sums from the exercise 2.1, sum number 7, 8, 9 and 10 and also example number 2.4 and 2.5. Example number 2.4, if the highest common factors of 210 and 55 is expressively in the form 55x minus 325, find x. In the sum, the highest common factor, that is HCF of 210 and 55 are expressly in the form of 55x minus 325. To find the value of x, to find HCF of 210 and 55 using Euclidean division algorithm, A is equal to BQ plus R. A is dividend, P is divisor, Q is quotient, R is remainder. 210 is divided by 55. 210 is divided by 55 3 times. 3 into 55, 165. 210 minus 165, we get 45. 45 is the remainder. Q3 is the quotient. 210 is equal to 55 into 3 plus 45. Again using Euclidean division algorithm. Now 55 is the dividend, 45 is the divisor. 55 is equal to 45 into 1 plus 10. 1 is the quotient, 10 is the remainder. The remainder is not equal to 0. Again using Euclidean division algorithm. Here 45 is the dividend, 10 is the divisor. 45 is equal to 10 into 4, 40 plus 5, 45. Here 5 is the remainder. So, remainder is not equal to 0. Again using Euclidean division algorithm, 10 is equal to 5 into 2 plus 0. Now you get the remainder is 0. So 5 is the HCF of the given number. The remainder is 0. Therefore HCF of 210 and 55 is 5. Therefore HCF is expressively in the form of 55x minus 325. Already you know. That's equal to 5. 55x is equal to 5 plus 325. 5 plus 325, 330. 55x is equal to 330. X is equal to 330 by 55. 330 is divided by 55. The quotient is 6. Remainder is 0. So the value of x is equal to 6. The value of x is 6. Example number 2.5. Find the greatest number that will divide 445 and 572, leaving remainder 4 and 5 respectively. In the sum, two numbers are given, 445 and 572. That number is divided by a number. When 445 is divided by that number, we get the remainder is 4. And 572 divided by that number, we get the remainder is 5. To find the number. Solution. 445 minus 4. 4 is the remainder. Minus we get 441. 441 is exactly divided by the required number. 572 minus 5. 5 is the remainder when that number is divided by 572. We get 567. 567 is exactly divided by that required number. To find HCF of 441 and 567 using Euclidean division algorithm. 567 is equal to 441 into 1 plus 126. Here dividend is 567 and divisor is 441. 1 times 567 minus 441, we get 126. 126 is the remainder, 1 is the quotient. Remainder is not equal to 0, so 441 is not HCF. Now, again, using Euclidean division algorithm, 441 is dividend, 126 is the divisor. 441 is divided by 126. 3 into 126, we get 378. 441 minus 378, we get 63 is the remainder. 441 is equal to 126 into 3 plus 63. Remainder is the 63. 126 is not HCF. Again, using Euclidean division algorithm, 126 is dividend, 63 is divisor. 126 is equal to 63 into 2 plus 0. Here, remainder is 0. So, 63 is the HCF. The remainder is 0. Therefore, HCF of 441 and 576 is 63. The required number is 63. Exercise number 2.1, sum number 7. Find the largest number which divides 1230 and 1926, leaving remainder 12 in each case. Given two number is divided by a number. That number divide each number, we get the remainder is same, 12. Find that number. 1230 minus 12. 12 is the remainder. So 1230 minus 12, we get 1218. 1280 is exactly divided by the number. 1926 minus 12, we get 1914. That 1914 is exactly divided by the required number. To find HCF of 1218 and 1914 using Euclidean division algorithm, we get is here 1914 is the dividend, 1218 is the divisor. 1914 is divided by 1218 one times. 1914 minus 1218, we get the remainder is 696. 696, the remainder is not 0. So 1218 is not HCF. Again, using Euclidean division algorithm, now 1218 is the dividend, 696 is the divisor. 1218 is divided by 696 one times. 1218 minus 696, we get 522. The remainder is 522. So 696 is not HCF. Again, using Euclidean division algorithm, now 696 is the dividend, 522 is the divisor. 696 is divided by 522 one times. 696 minus 522, we get the remainder 174. Now also the remainder is not equal to 0, so 522 is not HCF. Again, using Euclidean division algorithm, 522 is the dividend, 174 is the divisor. 522 is divided by 174 3 times. Quotient is 3. 3 into 174, we get 522. Remainder is 0. Now remainder is 0. The remainder is 0. Therefore, the HCF of 1218 and 1914 is 174. The required number is 174. If D is the highest common factor of 32 and 60, find x and y. Satisfy D is equal to 32x plus 60y. Here in the sum, 32 and 60, HCF of 32 and 60 is D. The D is expressed as D is equal to 32x plus 60y. D is HCF of that number. Find x and y. Given D is HCF of 32 and 60. To find HCF of 32 and 60, 60 is the dividend, 32 is the divisor. Using Euclidean division algorithm, 60 is equal to 32 into 1 plus 28. Here remainder is 28. Again, using Euclidean division algorithm, 32 is the dividend, 28 is the divisor. 32 is equal to 28 into 1 plus 4. Here remainder is 4. So 28 is not HCF. Again using Euclid division algorithm, 28 is equal to 4 into 7 plus 0. Here remainder is 0. Remainder is 0. Therefore HCF of 32 and 60 is 4. Here D is 4. Given D is 32x plus 60y. D is equal to 32 minus 28 into 1 from 2. D is equal to 32 minus 1 into 60 minus 32 into 1 from 1. D is equal to 32 minus 1 into 60 plus minus into minus plus 32 into 1. 32 2 times 32 into 2 minus 60 into 1. 32 D is equal to 32 into 2 plus 60 into minus 1. 60 into minus 1 minus 60. 32x plus 60y is equal to 32 into 2 plus 60 into minus 1. 2 replace x and minus 1 replace y. So x is therefore x is 2 and y is minus 1. 9th sum. A positive integer when divided by 88 gives the remainder 61. What will be the remainder when the same number is divided by 11? A positive integer is given. That positive integer is divided by 88. Leaves a remainder 61. That same number is divided by 11. What is the remainder? Given B is 88, that is the divisor, and R is 61, that is remainder. Using Euclid division algorithm, A is equal to PQ plus R. A is the dividend. Going to find the number A, the integer A. A is equal to 88Q plus 61. A is equal to 88 written as 11 into 8. 11 into 8Q plus 61 written as 55 plus 6. 55 plus 6, 61. A is equal to 11 into 8Q plus 55 is written as 11 into 5. 11 into 5, 55 plus 6. Here 11 is common in both set. Okay, taken out. 11 into 8Q plus 5 plus 6. This part is divided by, exactly divided by 11. We get the remainder is 6. Therefore, when the same integer is divided by 11, the remainder is 6. Two positive integers are said to be relative prime or co-prime if their highest common factor is 1. And prove that two consecutive positive integers are always co-prime.
Yes, very good.
Let x, x plus 1 be two consecutive integers. Let HCF of x and x plus 1 be n. Then n divides x plus 1 minus x. That is n is equal to 1. HCF of x and x plus 1 is 1. Therefore, x and x plus 1 are co-prime.